Alright, so in order to do this problem, we first have to look back at earlier problems to get some information. So from the earlier problems, we have established that the melting temperature, or the melting point of substance X, is 190 Kelvin. We have established that the boiling point is 250 Kelvin. We've established the specific heat of the solid is 1.11 joules per gram Kelvin. The specific heat of the liquid is 0.67 joules per gram Kelvin. The specific heat of the gas is 3.67 joules per gram Kelvin. We've also established that the heat of fusion is 0.75 kilojoules per mole, and that the heat of vaporization is 5 kilojoules per mole. So if you haven't figured out how these values were reached, you need to go back and look at those, but these are essential to doing this problem. So now we have to plot out what's going to happen here. So this is not a simple matter of heating up the substance from 20 to 300 Kelvin. We can't just do this all in one go, because there's a number of phase changes that occur along the way. So what we got to do is plan this out in steps. So our first step is that we have to heat this substance, heat substance X, from 20 Kelvin to as hot as we can get before we encounter a phase change. And our first phase change occurs at 190, so we're going to heat it from 20 Kelvin to 190 Kelvin, and then we're going to be stuck. So that's our first step. Our second step now is going to be to actually melt substance K. So that is going to be at 190 degrees. Or no, 190 Kelvin. No degrees in Kelvin. So it's not going to change temperature, but it's going to go from being a solid to a liquid. And now we're going to have a liquid at 190. So I'm going to now heat substance X as a liquid at 190 to as much as I can possibly get again. And we hit another sort of toll booth or stop at 250 Kelvin, which is where it's going to boil. So that's my third step. Let's see where this is going. After that, now I have to boil this. So step 4 is now going to be to boil substance X at a constant 250 Kelvin. So that's going from a liquid to a gas. And my fifth step now is going to be to heat that gas, heat K at 250 until our final temperature of 300 K. So this is a 5-step problem. So essentially we need to calculate the heat for each of these 5 steps and simply add them together. So that's the process that we are going to follow and go through now. So the first thing I'm going to do is heat X from 20K to 190K. So I am going to erase this area here so that we have some room for that. So I'm going to, so to use this is a change in temperature. I'm going to need to use Q equals M times C times delta T. So this is a solid. So first off, the mass is 200 grams, so that's never going to change. So this is going to equal 200 grams times the specific heat of the solid, remember, because it's a solid. So times 1.11 joules per gram Kelvin times it's changing from 20 to 190, so that is 170 Kelvin. So I'm going to calculate that, and so that total heat, 200 times 1.11 times 170 is about 37,740 joules. So that is how much heat it takes for the first phase. The second phase is now to melt this solid, and unfortunately that's a different equation. That is Q equals mass times the heat of fusion. Excuse me, is not mass, it is moles. And we weren't given moles, but we were told the molar mass of the substance is 12.5 grams per mole. So 200 grams of this substance, 12.5 grams per 1 mole. I'm going to calculate that. And 200 divided by 12.5, I get 16 moles. So I have 16 moles of this substance I want to melt. And remember, 16 moles, it takes a total of 0.75 kilojoules per mole to melt it. So I'm going to multiply that out, and I'm going to get 12 kilojoules. However, that's not going to be compatible with my other units, which are in joules, so I'm going to have to convert that. So every kilojoule is 1,000 joules, so it's going to be 12,000 joules required for this second step. All right, so I'm going to, again, erase. I'm sure there's a more efficient way to do this, but you're going to, I guess, have to deal with what I give you right now. So next, we are heating it up as a liquid. So same equation. If we're heating, it's Q equals mc delta T. So 200 grams. However, now it's a liquid. We can't use the specific heat of the solid. We have to use the specific heat of the liquid, 0.67 joules per gram Kelvin. Times change in temperature is now 60 K. It's going from 190 to 250. So I will multiply and get that. So 200 times 0.67 times 60 K is 8,040 joules. So this is pretty much all you do the whole way through. Now we're going to boil it. So again, a phase change uses Q equals N times delta H. This time will be vaporization because we are vaporizing it. So again, it's the same number of moles as before. So if we remember that from before, it was 16 moles. The heat of vaporization was 5 kilojoules per mole. So 16 times 5 is going to give me 80 kilojoules. Once again, that's not really compatible. I convert that to joules, which is 80,000. Notice where the energy is going here. Look how much is being used to vaporize it, because that's a pretty energy-intensive process. These other ones didn't take much to heat it up as a liquid. It took a pretty good amount to melt it. It took a lot because there was a large temperature change to get it to heat up there. But all right, one more step. And so our final step now is we have, again, 200 grams. We're going to use the specific heat of a gas now, 3.67 joules per gram Kelvin, times the final temperature change is 50 K. So I'm going to do 200 times 3.67 times 50. So my final step is 36,700 joules. So that's how much it takes for each individual step. And now to get the total amount of heat, it's just a matter of adding these 5 values together. So 37,740 plus 12,000 plus 8040 plus 80,000 plus 36,700. My total heat required is 174,480 joules. And I would probably round that off at least to 174,500 maybe. I don't know. Either way, that's good. So that's the final answer. So, all right.